Okay, today I'm just going to talk about, you can go to the next, I don't know, here's the next slide, okay. Talk about myself real quick. I'm a chemical engineer. I'm a Lean Six Sigma black belt. I have 17 years in the chemical industry. I currently am the quality and continuous improvement manager for our site in Savannah, and I'm a Navy veteran. And the reason why I bring that up, usually I wouldn't bring that up, but it's kind of relevant to some of the things that we're talking about. I'm going to talk about why people here may be interested. We were able to get a 50% reduction in our process safety incidents at our site without a capital investment. And we are capital constrained in our specific business. We're capital constrained and we're fixed cost constrained as well. And so I thought that might be interesting to people working here or that are at this conference to discuss some of this. Now, when I say process safety incidents, I want you to keep in mind that we're a responsible care company, and we actually measure process safety incidents that we call them process safety incidents, but they wouldn't necessarily be a process safety incident under API 754, which is really the governing body for process safety in the U.S. We have a lot more strict look at it. So something like a water leak could be considered a process safety incident, and we have called them that. But regardless, it's something that might happen that we didn't want to happen. So what I did was I essentially wanted to apply this to what we were doing at our site. One of the things that was in our objectives was to improve process safety incidents. So it's going to feel like I'm going in a few different directions here, but I just kind of want to bring everybody into the fold to follow my logic a little bit. Our learnings from Texas City said that this accident triangle that's represent these two accident triangles. This is the incorrect way of thinking of it. In the behavioral, in the employee incident triangle, this one is typically noted by. One of the things that you would typically see there is that unsafe behaviors and near misses end up resulting in OSHA recordables and all the way up to these very serious injuries. And this at the time, 2005, basically it was just a scaled up triangle to talk about major accidents that occur in industry. But we learned that that's incorrect. And in fact, this is probably the right way to think of it. You've got an injury triangle that you work at the bottom of the triangle to pull down these behavioral-based incidents, and then you have these process type of things that occur that could lead to a major accident, like exceeding control limits, temperatures, pressures, losing your protection layers. But the interesting thing here is these two overlap, and that overlap there is behavior, okay? And so you still have behavior that's occurring between both of them. And so in the past, like a lot of people would think, well, that's a control system issue, or this is this problem or that problem. So things you ask yourself. What I did, I says that in any high risk industry, what's paramount for safety? And a lot of people will say that mechanical integrity, non-steady state operations, alarm management, which is a major problem in every plant that I've ever worked in. Your success of automation, and if you don't know what automation is, it's a Lean Six Sigma term. It's an old term developed by Shigeo Shingo, and it separates workers from machines through mechanisms that detect production abnormalities. And there's 23 stages between purely manual and purely automated. Okay, so if you do a little bit of reading on that, you'll find out is the success of how well that human-machine interface is matters. Okay. And because you want the employees to understand that. And then are your employees making good decisions? Because great decisions actually matter, okay? At the end of the day, when you're dealing with process safety, they matter. So one of the things that people don't really realize, and we didn't realize, was how important the data was that we weren't using, okay? And so here's where my Navy experience comes in, okay? So when I was 18 years old and I left home while I still knew everything. I joined the Navy and worked on aircraft carriers, and I was on the flight deck. And one of the things is I didn't realize it at the time, but I was working in what's considered a high reliability organization, And I believe that the father of high reliability organizations is Hyman Rickover. So if you ever read a little bit about him, he was the father of nuclear navy. But what I learned there was that high reliability organizations have a reluctance to simplify their interpretations. They have a commitment to resilience. They defer to expertise. They have a sensitivity to operations, and they have a preoccupation with failure. And so what's really neat about that, the way I describe it is that high reliability organizations, or HROs, are good at identifying weak signals, and they have a mindfulness about what they do and how they do it, okay? And so another thing to keep in mind is that since Chernobyl, okay, so if you want to think about it in terms of really dangerous type of safety incidents, since Chernobyl, there have been 57 accidents, okay, nuclear accidents that have occurred, okay? And of all the nuclear accidents that have occurred, I think there's around 99. 56 of the 99 occurred in the U.S., okay? But the thing that's amazing is that the U.S. Navy was putting submarines in the water and Navy aircraft carriers that have nuclear-powered vessels in the water. We've never had an accident. And so if you understand that and you're reluctant, you have a preoccupation with failure and you don't want to simplify it, you follow those principles, then you can take these things and this is the way I view it. It's not necessarily right, but I figured it would be helpful for people to understand where I was coming from. Is the first thing is that you have principal agent factors, and people are going to think, well, that's your employee reward system, right? Well, it is in a way. The way I view it is I kind of pair that principal agent factors into the information factors. Principal agent to me is, if you guys have seen the Bradley curve, not sure if anyone's ever seen it, but it's a behavioral-based curve that people typically point to. It comes from the old DuPont stop stuff and methodology, and basically it says that you start as independent, you start out as being dependent on someone telling you how to deal with safety, to being interdependent, to becoming independent, to becoming interdependent as the final stage. Well, if you're interdependent, that's great, but with employee turnover and things like that, it tends to move people back up on that independent curve, so they're only caring about themselves at that time. So you have to know where they're at. The other thing is what I call asymmetrical information. You don't have good information. The operator knows what he can and can't do. He has perceived, he has risks that he thinks, or things that he thinks he needs to do. Maybe they're not necessary. Engineers believe that they should be doing certain things. Managers think they should be doing certain things, or they have a perception of what they're doing or what's involved in their job, and the only real person understands is the guy in the field. And then you have what I call non-value-add activities. This is a Lean Six Sigma thing. I'll talk a little bit about that. And then you want to prioritize your focus based on your risks and generate a dashboard for them to use using all your data sources. So for me, so what I did was, real quick too, let me go back here real fast. Yes. Okay, all right. Okay. I'm worried about having time because I always run over. One of the things I wanted to talk about is what we do is we break our activities into different activities. In Lean Six Sigma, they teach you that you have value-add activities, non-value-add activities, and business value-add activities, right? And so value-add activities have three characteristics. The first characteristic is it changes the product. The second characteristic of a value-add activity is that the customer is willing to pay for it. And the third characteristic of that value-add activity is that it's done correctly the first time. The issue is that every other activity falls under business value-add or non-value-add. And non-value-add activities are basically your lean wastes of transportation, inventory, motion, anything that creates inventory, motion, overprocessing, overproduction, defects, and not using human talent. So outside of those, everything else we call our business value add. In a typical industry, it's between 2 and 5% of the activities that your employees are doing in the field are value add, okay? We happen to be a little bit further down the road at our site, but it's not a very high number. So what are they really doing? It goes back to this asymmetrical information thing. How do you get them prioritized, or how do you get their focus on the things that really matter? So what we did was I used this simple Lean Six Sigma tool called Day in the Life of Studies. It's a lean tool. I actually put production engineers in the field, made them work 10 shifts with the operators, okay, and told them that we were there going to help. We were there to help them. And so first we did brainstorming sessions and things like that. We involved our operators, we involved our engineers, we involved our EH&S people. And we basically broke out their activities into a pie chart. And in our case, we were 14% value add, and we had a significant amount of business value add and non-value add. But when we went into the NVA activities outside, we analyzed the business value add activities. Do we still want them doing this checklist that's been done 3 times because the operations manager that was here twice, 2 operations managers ago wanted them to fill out this form that nobody was collecting, that kind of thing. Oh, we found out a whole bunch of those that we could get rid of. And then we found out in the non-value add activities, we found out situations where, in our case, it was pretty amazing. We had a pump, and one of the pumps was causing about, it was like 60 or 70% of our downtime because someone had removed a screen, okay, upstream from a sump that was getting into their clarifier pumps, and they were having trouble with it. But it was taking one of our operators as dealing with one of our more critical areas of the plant. It was taking him away, and he was constantly having to go out there and deal with it. So until you really fully understand, when I've learned about it, I asked the engineers, I said, well, did you guys know about this? Yeah, it happens sometimes, but we didn't know how bad the problem really was. So what we did was we used like a 5 whys, let them figure out. We did root cause analysis to find out what was causing this big thing. You could do more sophisticated. In our case, it was pretty easy. Put another strainer in there. So, but we ended up trying to reduce all of the non-value add activities. That way, now he's got some downtime. He's got a little bit of time to focus on what's really important. And so, we looked at everything that we could do. We used failure modes and effects analysis to do it, and we developed projects that came out of it. And so we developed these work streams. Okay, this is what we want to work on. So once we got it narrowed down, we got it into the work streams. And essentially, we use a pretty rigid scoring system in failure modes and effects analysis because we rate severity, occurrence, and detection. Well, in our case, at our site, we're not a super automated site. I work at a catalyst plant, and it's not like an API. It's not a refinery. I came from refineries before, but in my past, but we didn't have a lot of sophisticated data. We did have a lot more than I thought, though. We had LIMS systems. ERP is our exposure reduction process. We've got a lot of data that our people collect around potential plant hazards. We have maintenance data, historian data. We have data that comes from training on who's qualified to do what and where, and all of our process safety data and our process hazard data. So basically, this is the old Swiss cheese model. We were trying to figure out what we had in our data lake to figure out how we were going to help protect from having these incidents. So the question I always ask is how does this chart? This is a typical SCADA, right? To me, how does this help the employee? It's pretty common. If you talk to most of your site managers, they're not going to see anything. There's nothing wrong with that. The pump's red probably means it's not working or something is wrong. But the thing is that on your failure curve, it's already happened. Usually, it's happened before there's a problem. And we did talk earlier a little bit about alarm management. Alarm management is a huge problem because people just shut the alarms off and they silence them because they don't want to hear them. Because the operators want their alarms, the engineers want their alarms, safety wants their alarms, everybody's got alarms, and nobody knows what's really going on because they end up shutting them off. So, for us, real-time analytics, we wanted to find out what we could do with our existing systems. I don't have capital, and I don't have, and I have a very limited fixed budget. Well, we end up using NWA focus or NWA software because I don't need a server to get what I want out of it. And we were able to combine all of the data and get that data into one system where I can look at multiple pieces of data feeding it. Heck, we can even take, like for instance, if I have a sump that's near a stormwater drain that I know has been a problem for us because I can't have anything get out to the outfall. If the weather forecast is not very good that day, it can pull the weather forecast and tell them we have a potential issue if it's going to rain. So they need to be on alert for it. But the reality of it is that the traditional alarms are happening when the problem is occurring, and it's not happening before the problem is occurring. So I think by being able to use this real-time analytic alarming, it can help. And like Jerry, we did dashboard. We ended up with dashboards as well. So for us, what we wanted to do is, first thing we did was I said, oh, well, where's our biggest problems with process safety incidents? Well, at our site, we don't have lots of tanks that meet the high standards of BASF, and they're a work in progress, and we need capital to get them there. But we have things that in some cases, we don't even have like level indication on these little tanks, and we're not allowed to have a spill, okay? They don't want us to have a spill, but we don't have a way sometimes to measure it. So we wanted to try to find ways to infer when things were being filled and then try to figure it out. And this software has a capability of doing that. So what we did is we did data analysis of our accident incident database, and we found hotspots in our site. And we said, you know what? Tanks seem to be a problem. We've got over 200 of them. Let's lay them out. Let's do root cause analysis and try to figure out what are the biggest risks and factors that are going to cause me to have a problem with the tank. And so what we ended up doing is we kept narrowing it down, and we narrowed it down to, these are my actual pictures from my sessions with our operators. So we narrowed it down to a list about this big, and we got it down to our first 2. And out of 200 tanks, we're working on the top 13 is the ones that we see as having the highest risk through our rating system. We included everyone in the system. So if you use Lean Six Sigma tools and you're using an Ishikawa, if you've got 30 inputs, you pick 6, everybody gets 6 votes. You can use all 6 votes on one thing, or you can split it up and put one on whatever. So whatever you're passionate about, you can get. So it allows the operators to be in there and do it. But the main thing is that I took real risks and perceived risks by the operators in this case. Because once you start really prioritizing it, the real risks separate themselves from the perceived risks, and they feel like they got their voices were heard at the same time. So it's very important that you do it. So for us, in comparison to that SCADA that we had, this is an example. I can't show a lot of stuff because it's proprietary stuff that they won't let me show, but I did grab this. I was allowed to show you this. This is a simple dashboard that we have for one of the tanks that was always a problem. And basically, it's pretty simple. It's showing that, I'm missing a piece off of that. Okay, I'm missing a piece. But it's showing that the alarm has, it ignores any flows under 50 gallons a minute. So if they have other flows going in there that we know aren't going to be a real risk for an incident, it ignores it. But once they start transferring and the flows go up, this thing comes alive for them, and it lets them know, I've got how many minutes until the tank reaches 95% with the current flow rate. The percentage increase in level per every 5 minutes. So, and then which tank is currently filling, so they can go to another tank if they have to switch off. So it gives them that option quickly, and then what their current level is, and then here. If they click on it, and I didn't show these screenshots, but they have the SPC, so they can see the actual chart of it filling, and they can, and then if they have a rule violation, which we set up rules around how that tank should fill, this will go yellow or red, and then they have, and then if they're within this normal spec, that keeps them green. So, and then over here, which doesn't show because it's a little bit earlier version, it took us a little bit of time, but our document management system's hooked right onto this. So we don't have, everyone I'm sure has document management systems at their business. Well, we use Compliant Pro at our site. If I want to use Compliant Pro if I have a rule violation, it'll pull up that procedure when they click on it, and it gives them the response procedure in case you have an operator that doesn't really know what they're supposed to be doing. So this thing interfaces directly with it. And here's another one. It just kind of shows the same type of thing. We have rule violations. These are SPC rule violations. By the way, our old SPC software did not provide us with telling us which rules were broken. It really only said that you had broken a rule. And so this software really kind of helps us out because it tells us, hey, you broke this rule, and this is why it's relevant. So we can look that up. And then the specs, these are our specifications that we set for each one of these, and just kind of gives you an idea. Like I said, we just got through our IT to get we had some firewall issues with how our document management system linked up, and they got it fixed. So now we have all the documents. So if they have a problem with one of these parameters, they can quickly switch out and go and figure out what the troubleshooting guide says. And so at the end of the day, well, for us, the operator has a higher probability identifying weak signals, and that's something that a high reliability organization does. They make better decisions at the end, and the critical activities, because of our day in the life of studies, they become center stage, because the operator's critical activity prior to this might have been working on a pump, but now his critical activities are more focused on what we want them on. And then this visual factory, going from like having the DCS with all this busy alarms and everything constantly on there, going to a dashboard, I think it really it drastically improves everyone, because we have different views. So like the operator has his view of the dashboard, but the engineer has like a longer term monthly type of view of the dashboard and how many times something wasn't right. So they can take a look at that, So even though the operator might be dealing with correcting a situation, the engineers are seeing it at a different view, so they got a higher level view they can see, and they can still drill down to what the operator's seeing as well. And then, and essentially at the end, we moved from being in an area of functional failure to potential failure, so we move ourselves up on this curve, you know what I mean, to have a higher resistance to failure, and our failure being having a process safety incident involving our tanks. So our next steps are going to be like to go to the next. We're just deploying it one area at a time. We have it prioritized, and we're just working through our site that way right now. So our plan is to continue on with it. It's been a great addition for us, and Peter can probably Guilfoyle could give you some more information on that software, because I think it's I think for a lot of people we're not going to spend the money on servers and we're not going to spend the money on the infrastructure and the sensors, and when I can infer things without needing to have to having actually instrumentation in some cases, it's very helpful. So and that's about it. So